So hi everyone, this is Jay, your instructor for computer networks. In the previous session, we have discussed what is subnetting and why it is required. In today's session, we are going to see one example regarding to subnet for class C. So let's start. We know that the total IPv4 addresses are divided into 5 classes: A, B, C, D and E. Right now we are only interested for class C. So you can see that in class C, the first 3 bytes means 24 bits are for network ID and 8 bits are for host ID. So from the network ID, you will know that how many networks are possible in class C. So how many networks are possible? 2 raised to 24. So 1, 2, 3, 4 up to 2 raised to 24 individual networks possible in the class C. And in one network, how many hosts are possible? So that information you will get from the host ID. So the size of the host ID is 8-bit. So from that 8-bit, you will know that in one network, 2 raised to 8 hosts are possible. Means 256 IP addresses are there. So you can create a network of having 256 devices. But what if I want to create network smaller than that? Suppose I want to create network which has only 128 devices. And in that case, if you are purchasing one class C network, so you know that by default in class C network 256 addresses are there. And if you are purchasing one class C network to create network of 128 devices, so remaining IP addresses will be totally wasted. So that is the reason why we need to do subnetting. So subnetting is simply process of dividing network into smaller parts. So this is the one class C network which is given to you, which is 193.168.10.0. We know that in class C network, by default, there are 24 bits are for network ID and 8 bits are for host ID. Now, the value of the network ID will remain same throughout the network, and the value of the host ID will keep change as the host changes. But right now, I want to divide this network into subnets. So to do so, to divide the network into subnets, I will convert the host bits into network bits. So right now I am converting 2 host bits into network bits. So you can see that number of host bits are changed from 8 to 6. And the number of network bits are changed from 24 to 26. So 2 bits are converted from host to network. So what information you get from the converted bits? From the converted bits, you will know that how many subnets are possible. So right now the size of the converted bits is 2. So you will get 2 raised to 2 means 4 subnets. Let's see the subnet 0. Now I want to find the number of hosts in the subnet 0. So to find the number of hosts in subnet 0, you have to check the size of the host bits. Now what is the size of the host bits? Size of the host bits is 6. So you will get 2 raised to 6 devices in one subnet. So in subnet 0, you will get 2 raised to 6 devices. Means 2 raised to 6 host. Now I want to find first IP address in the subnet 0. So to find the first IP address in the subnet 0, we will set all the host bits to 0. So let's set all the host bits to 0. You will get 193.168.10.0. I want to find the last IP address of the subnet 0. So we'll set all the host bits to 1 and you will get 193.168.10.63. If you have already noticed, the value of the converted bits is remained same throughout the subnet 0. The value of the converted bits is 00 in the subnet 0 and that value is not changed throughout the subnet 0. Now let's allocate the IP addresses to the devices in the subnet 0. One more thing you have to remember, that in any subnet, the first and the last address will not be allocated to any device, because first address represent the subnet address and the last address represent the broadcast address. So first IP address is the address of the whole subnet, and the last IP address is the subnet of broadcast address. So what is the meaning of broadcast address? Broadcast address means that any message sent to the address 193.168.10.63, all the devices in the subnet 0 will receive the message, right? So what will be the IP address of the first device in the subnet 0? So the first device will get 193.168.10.1. That is the first usable address in the subnet 0. Then 10.2, 10.3, 10.4 up to 10.62. Now let's see the subnet 1. Now how many hosts will be there in the subnet 1? So the size of the host bits is 6. So there will be 2 raised to 6 hosts in the subnet 1. Now let's find the first address in the subnet 1. So to find the first address in the subnet 1, we will see the last address in the subnet 0. What is the last address in the subnet 0? It is 193.168.10.63. So if you increment 1 to the last address in the subnet 0, you will get 193.168.10.64, and in that case the converted bits will be changed. So what will be the first address in the subnet 1? It will be 193.168.10.64, and notice the value of the converted bit has changed from 00 to 01. Now I want to find the last address in the subnet 1. So to find the last address in the subnet 1, we will set all the host bits to 1, and we will not change the value of the converted bits. So the last address is 193.168.10.127. Again, you can easily notice that the value of the converted bits is same, which is 01. Again, first and the last address in the subnet is never used, because first address is for the subnet and the last address is for broadcast address. So let's allocate the IP address to the devices in the subnet 1. So the first device will get 193.168.10.65, and it is the first usable IP address in the subnet 1. Then each device will get 10.66, then 67, 68, 69 up to 10.126. Okay, now let's see the subnet 2. How many hosts will be there in the subnet 2? Now you can easily tell that, sir, the size of the host bit is 6. It means there are 2 raised to 6 hosts are possible in subnet 2. And I want to find the first address in the subnet 2. So now you can easily understand that value of the converted bits will be 10 in the subnet 2. So what will be the first IP address in the subnet 2? So this is the first IP address in the subnet 2, which is 193.168.10.128. And what will be the last IP address? To find the last IP address, we will set all the host bits to 1, but we will not change the value of the converted bits. So you will get 193.168.10.191. Again, first and last IP address are never used within a subnet. So what will be the first usable address of the device in subnet 2? So it will be 193.168.10.129, then 10.130, 131 up to 10.190. Now we want to find the number of hosts in the subnet 3. How many hosts will be there? 2 raised to 6, right? Now can you tell me what will be the first address in the subnet 3? So if you add 1 to the last address in the subnet 2, you will get the first address in the subnet 3. Or you can change the value of the converted bits to 1 1 and you set all the host bits to 0, and you can also get the first address in the subnet 3. So this is the first address in the subnet 3, which is 193.168.10.192, right? And what will be the last IP address? It will be 193.168.10.255. The value of the converted bits is same. And what will be the first usable address in the subnet 3? It will be 193.168.10.193, and the last usable is 193.168.10.254. Now if you increment 1 to the last usable address in the subnet 3, which is 193.168.10.254, you will get 193.168.10.255, which is the broadcast address in the subnet 3. If you further increment 1 to the broadcast address in the subnet 3, which is 193.168.10.255, you will get 193.168.11.0. So value of the network is changed. Are you getting it? Now I want to find the subnet mask for this example. So to find the subnet mask, we will set all the network bits to 1 and host bits to 0. And you will get 255.255.255.192. So this is how subnetting is done. This is the example that you need to find by yourself. You have to divide this given class C network into 6 subnets, and you have to find the first usable and last usable address in each subnet. So this is it for today's session, and if you have any doubt, you can feel free to ask me in the comment section, and in the upcoming session we will further see more examples for class A and class B. So thank you so much.